Welcome to Embedded. I am Alicia White alongside Christopher White. Compliance. It means boring things for those working on medical products or devices with FCC certification. It means something far more entertaining when you're talking about robotics. Our guest this week is Kari Love.
Hi, Kari. Welcome back.
Hi. Thanks for having me.
Could you tell us about yourself as if we met at a SuperCon or New York Resistor sort of get together?
Sure. I'm Kari. I wear lots of hats in my life. I'm really someone who makes things that are associated with fabrication and motion and softness. In my life, that's been things like costumes for Broadway film and television, as a spacesuit contractor. It's co-writing a book about soft robotics and also teaching about soft robotics.
Many of those things we'll be asking more about, but first we want to do lightning round, where we ask you short questions and we want short answers. And if we're behaving ourselves, we won't say, what exactly do you mean by that? Are you ready?
I am ready.
Favorite fictional robot?
Baymax.
Favorite non-fictional robot?
Oh, it's too hard. I don't know.
Do robots have religion?
Maybe.
On a scale of 1 to 10, where 1 is an electric toothbrush and 10 is ChatGPT controlling a ROS 2-based chassis to roam Mars, at what point does something become a robot?
For me, 2 or 3.
What is your favorite medium for soft robotics?
Inflatables.
What's your favorite soft robotics drive mechanism?
Programmable air.
If you were to write another book, what would it be about?
It would probably be about tech plus craft or digital fabrication with post-consumer waste.
Give a tip everyone should know.
If you can't fix it, feature it.
That's a good one.
It's like jazz.
So
you mentioned you wrote a book about soft robotics. Could you summarize that?
Sure. It was a book by Make. It's called Soft Robotics, a DIY Introduction to Squishy, Stretchy, and Flexible Robots. And it was meant to be a kind of maker or hacker introduction to making your own soft robots.
But it had a lot more theory than most of the Make books. I mean, it actually, in parts, seemed like a technical, not paper, but definitely an introduction to the whole field.
Oh, I think that was really intentional on our part. I think there's one thing about it that drew me to recommending that approach. One was that the majority of people don't actually make all of the DIY projects in craft books or in like maker hacker books.
I hope you don't find out how many I own having never made any of the projects.
Exactly. And so, I mean, part of the joy is the like aspirational, I'm going to build this. But also, I really feel like people are interested in these books because they're interested in the topic at large. So I really recommended to my collaborator and to our editor that we include a lot of information about why soft robotics. Because I think that for people who have never heard of soft robotics, it's a little mysterious why. I mean, there's the it's cool factor, but like it's very difficult in some ways to build a soft robot, especially for all the reasons that also make them great, that they have nonlinear behavior and surprising behavior. So to take on those challenges, then you have to have a reason. The other thing that I thought was why we included a lot of technical information and like what else was going on in the field is because a lot of the projects in the book are things that are very similar to other things out there. And we didn't want it to be like ripping off someone else's work, but instead it's that, we're part of a discussion of the larger field of soft robotics. So if we are building a project, there are multiple projects that have similarities with it. We're just riffing in the space. We're sharing what the baseline knowledge is, as opposed to like just stealing someone else's work and like publishing that. So that was another reason why it's great to include, what else is going on in the field? What's the history in the field? I also just really love the idea that, some of the people who read this, like, may not care about that at all. Well, they'll just want to see the projects. But for people who get really drawn into the idea of what soft robotics is, and also what the possibilities are, they have breadcrumbs to go and do more self-guided learning on the topic.
Was your editor originally in favor of this idea, or did they push back?
I don't think we ever got pushback on what could go in the book. I think they originally approached Matthew Borgatti, who's the collaborator on that book, about making a book that included a robot of his that's not even in the book in the end. And so that was their idea of what the book needed to be. Ultimately, that robot didn't end up in the book because none of the technical editors or anyone else who tried to make it could reproduce it because it was so difficult to make. So we ended up making much more accessible projects to put in the book. And then we also provided all this context. And, I think the thing that we were passionate about was to invite people to design their own robots. And I think that that's, to me, what all of the kind of background information invites you to do.
That makes a lot of sense. But you did say you don't usually do it unless you have a need for something about soft robotics. In what case does someone need a candy-based robot? Other than it is awesome, which I won't deny.
So it's so funny because I think it's this back and forth between like the idea of a blue sky future. So if you ask someone what a candy robot is, who's like an academic or working in like a highly technical company, the answer they will give will be about like the future of healthcare robots. There are these scenarios in which we will need to be able to eat a robot and have it do something in our digestion but not harm us. So that will be your blue sky answer. And then there's the answer, which is right this moment, which for me is like, I teach and make in an artistic context. So for me, like there's an immediate artistic reason to make a candy robot, which is, as far as interactive art goes, it engages all five senses and then it literally becomes part of you. And so that idea excites me. And then I think there's like all these kind of in between the blue sky future and the like what's achievable right now and artistic intent.
The book was published in 2019 or end of 2018. And so it's been a few years. How much has changed?
In terms of what is available to people to work on and like what information a person at home can have, not a lot, surprisingly. I actually am really surprised how many people who come up to me and they're like, yours is the only book I've ever read about soft robotics, just because there aren't any. The other books I see about soft robotics are only engineering textbooks that are, very expensive and like not very accessible. So this is kind of, other than online content, which, not to say that online content isn't amazing. There's tons of it and super useful. But if what you want is a physical book to read about entry-level soft robotics, it's still kind of the only game in town. In terms of the greater field of soft robotics, I would say like the landscape for commercialization still hasn't grown or panned out. I would say the same things that were looking the most marketable then are still the most marketable now, which is grippers. In terms of other things that are soft robotics that you would see that are commercialized, you would still see the same things you saw then, which is things that I would call a soft robot that the people making them would never call a soft robot. So that hasn't changed. But I would say the research landscape has really expanded. It's since 2018, 2019, and now there are more and more laboratories and schools all over with people doing their master's work or their PhD work on soft robotics now. And I think that that is where it's changed rather than it changing at like the market and commercialization level.
I often expect technologies like this that have a whizziness that isn't necessarily obviously applicable to lots of things. I mean, medical, all the things you said, but I kind of expected to see it in toys.
I think you do see it in toys, but again, no one will call it a soft robot.
Do you mean the dancing blowy things? Would you call that a soft robot?
The what?
Do you mean like the things that are advertisements in front of car dealerships?
Yes, that's what I mean.
I mean, again, on the scale of call it a soft robot to not call it a soft robot, I would call it a soft robot. But again, nobody else would. But I mean, even things like someone was talking to me about pneumatics for cosplay. Mm-hmm. Like, we haven't really seen pneumatics for cosplay. And I was like, well, we haven't really seen computerized pneumatics for cosplay, but they were like those fabulous hats with little bulb pumps and then the ears flip up. And, you know, if we stuck an electronic pump on that, like no one would have a problem calling that a soft robot. But because we still have a hand pump, nobody calls it that.
The drive for soft robotics has been a barrier. I mean, it was a barrier to entry for me. I kind of wanted to play with all the things in your book, but I didn't want to end up with a bulb at the end. I wanted it to be a robot. There was the winner of the 2021 Hackaday Prize was, in fact, soft robotic drive, Flow.io. Are you familiar with them?
I am. I have to say there are many things that project are doing super well.
Can you describe it, Alicia? I don't remember that one.
I was going to ask her to describe it.
That's the next.
Could you describe it, Kari?
Sure. I mean, you might be able to describe it better than me, but essentially it is a miniaturized, wearable pneumatic drive system that has built-in pumps and built-in valves, and it has some modularity that some units you can add a bigger pump, for example, if you need more air, or they have a couple of other kinds of units that I'm not remembering right off the top of my head. I would say those are the things that they're really doing best. Is they have a GUI that is really wonderful. They have miniaturization down, and they have made it wearable. They have 5 sets of valves, so you have a number of channels, so you can program quite complex things. In terms of drive systems that are out, though, I would say there's always trade-offs. So it's, you know, it's trade-offs all the way down. So for me, the trade-off on Flow.io that is difficult for me is accessibility to the unit. So that's a current project for someone's PhD. You can't really get your hands on one. In order to build one, it's very, very expensive. It's like probably $800 in parts. So that's a big barrier to entry. And it's also like very complex to build. Now, there have been past projects that are drive systems for pneumatics. There was Nutritious. There's the Soft Robotics Toolkit one. Those ones really suffer from not being maintained and like have their own drawbacks. And actually, the Flow.io people have done a good job of like breaking down the different Arduino controllable pneumatic systems and talking about like the pros and cons. So with Nutritious, it was that it was both very expensive to get, and also it didn't have the pumps on board. So you had to get your air source separately from the control unit. For the Soft Robotics Toolkit, the barrier to entry was also, again, price. It was about $800 in parts to build. The one that I teach with in my class was actually from one of my past students, decided for his master's thesis. Amitabh Srivastava is the person who developed programmable air. So The good thing about programmable air is that the master's thesis included crowdfunding in addition to, building and the research surrounding it. So that means compared to other units, there have been more out in the world. More than 500 units have been sold, which for a programmable pneumatic system is a lot. It really wins on price point, and it's very remixable. Where that one is that one, the price point is about $199, and sometimes you can get an educational discount. The downside to that one is the documentation isn't necessarily where you need to be for early, easy onboarding. And I would say that's probably true of all of the available systems that the people developing them. It's hard for them to devote all the time to the hardware and also devote all the time to onboarding new users. And then another pro about the programmable air is that it is very remixable for a person who already understands pneumatics, but again, that's maybe not obvious. Where it falls down is the form factor. It's a little clunky. It's definitely not miniaturized. It's definitely not wearable. And although there's some ability that you can make them primary and secondary units, so you can end up with a system that is 9 valves and 6 pumps, you still... It ends up being a very large and very clunky system. So those are the pros and cons. So I would say of the current generation things that are out, you're going to be looking at Flow IO, or you're going to be looking at programmable air, and then you're going to be looking at those trade-offs.
Is it, with traditional robotics, servo motors and things cost, 5 cents and are quite miniaturized now, but they weren't always. I remember when I was younger, doing radio control stuff, servos were large and clunky. Is that a matter of inherent complexity of the pneumatic systems that they're not there yet, or is it just it's still kind of early and the research and industrialization hasn't happened as much as it has in traditional controls?
Yeah, I'm not really sure. Unfortunately, this kind of hardware is not where my strong suit is, because my strong suit is in the the compliant part of it, the
Gotcha.
soft part, the materiality of it. So the nitty gritty of how we're going to be costing pumps and valves is not where my area of expertise is.
Fair enough. There's a lot of questions there because, as you say, it's quite expensive, it's quite complicated, and there isn't the equivalent of a DC motor that you can just try out.
Mm-hmm.
Maybe someday.
I think that one of the things that's interesting about teaching with programmable air in my class is that it seems like having a kit like programmable air or Flow IO is really important for people to be able to envision what pneumatics can do. But once they actually understand what pneumatics can do, a lot of them opt to program their own thing.
Well, that's kind of disappointing.
How is that disappointing?
Sometimes I just want it to work. I don't need another pet. I just need a tool that I can skip to the end and do my application.
Yeah. That makes sense. And I think it's mostly that I would say in terms of what the capability people are trying to get that maybe they're struggling with is either they want to do it cheaper. So that's one. They want to do it smaller. That's the trade-off between miniaturization versus not miniaturization. They want to make it wearable. And they want to be able to make it either high pressure or high flow rate and have vacuum. So again, because of the complexities of the pneumatics, you can end up with all different ways that you could change what you're doing. Maybe you want to use compressed air instead of using pumps. Maybe you want to use a larger pump. Maybe you want to daisy chain your pumps so you're getting higher pressure. Maybe you want a higher flow rate. There's just all of these things that people end up deciding they need, that it ends up being that pneumatics isn't a one-size-fits-all solution.
I suppose that makes sense. And I am really glad that there are some more kits to try out. Because, yes, as you said with the Flow IO, it's kits. and they're expensive, and you can buy 10 kits and it's less expensive, but not that much less expensive. I mean, it's good if you're teaching a course. You teach a course, and it's at NYU where you teach, right?
Yes.
Could you come out to California and teach one?
If someone wants to fly me and pay me, I'm happy to teach.
How long have you been at NYU?
I have been at NYU since, I think, 2016. It's been a long time.
And you teach another course there, which I came across as I was looking up what we should talk about. And it's called Considering Religious Robots. And I have so many questions, like, are the robots religious, or are we worshiping the robots? Is it considering religious robots or considering religious robots? I mean, what is this class about?
So the genesis of this class was kind of twofold. So one was that I was doing research with a PhD candidate at Cornell Tech named Natalie Friedman, who's doing her work on robots wearing clothes. And why would a robot wear clothes? And can we add capabilities to robots by having them wear clothes? And so I was bringing her lots of examples of robots wearing clothes in the world and talking about them. And one of the things I kept noticing was that you would see robots wearing religious vestments. And it was a recurring theme. And I was very interested in why is this a recurring theme? So I kind of dug deeper and saw that there were lots of robots that were built or working in religious contexts that weren't really being considered. So that's where the considering comes into this. And then kind of the next stage of what happened was that the pandemic happened. We switched to online teaching, and soft robotics was not something the department felt I could teach online because it's so fabrication heavy. So they said, is there anything else you'd be interested in teaching while we're in online only university? And I said, well, I have a couple of ideas, and one of them is this religious robots topic. And they were like, this sounds fascinating. We want you to do something with it. So what I ended up doing was kind of looking at all of the existing robots working in religious contexts and really using that to ground where the conversation would go. I have found to date about 45 robots that are working in religious contexts, but I look forward to finding more that I have not yet uncovered. And the way I structured the course was that I built it as a co-learning class. So I got a lot of people who were experts on one aspect or another to give talks to us. And then I would kind of facilitate finding the people we would hear from and then have discussions about what we learned. And then also the students would bring topics that came up for them, and they would guide the discussions as well. So that ended up being super broad. We're talking about things like, religious work as labor, about caregiving. We're talking about religious tools as a way to make you be more observant. We're talking about doing religious rites for robots. That certainly happens in the world. We talk about things like, what about digital afterlife? Or how is religion effective if we decide to become transhuman cyborgs? So it's kind of every aspect of where religion is touching against technology and robotics.
Could you give examples of robots working in religious contexts?
Some of them are quite mundane. So for example, during a swine flu outbreak, someone built what is essentially like a soap dispenser in a bathroom that can dispense holy water. Because where it was, they were worried about waterborne illness, and they wanted a way for people still to be able to get their own holy water, which was something that was common in the churches there. And so essentially you put a little thing under it, you can capture your own holy water from a closed system instead of an open system. Another example would be there's a Buddhist robot in China that is a chatbot. And it rolls up to you, and if you talk to it, it will answer some religious questions for you. But if you ask it a question it doesn't know, it will tell you that it's a very stupid robot and that you should speak to a monk instead. So again, and then I'm really into things that people would never call a robot. So one of the things that I would say is like, there's a lot of technology that's to like Shabbos elevators. They stop on every floor so that the fact that you're not allowed to press an elevator button if you are Orthodox Jewish, is accounted for in public settings.
All right. Yeah. I mean, that all makes sense. It was kind of what in the world can you mean? But those all, yeah, okay, I can see how that would be useful. Yes.
Do you touch on what religions say about technology? Kind of the flip side, because it doesn't seem like something that's explicit really in a lot of religions being
Thou shalt not robot.
Thousands of years old, a lot of them.
I mean, there's golems, so it's not like there's...
Sure, yep. Okay, that's a good example.
Well, and I think one of the questions that comes up is, can a robot join a religion? And golems is a great example. So again, pretty much every religion is not a monolith. So if you ask the question, like, can a robot convert to Judaism? That is a question that is asked. And, some rabbis come down on yes, and sometimes come down on no. And some of the people who are coming down on yes are like, well, there is some discussion whether or not a golem can be part of minyan. And so they use existing, religious debates to then inform about whether the role of robotics. And different religions are more accepting and less accepting of robots. Like in Islam, there's definitely a much higher occurrence of people really not wanting humanoid robots. And, some of the discussion is like it's tied to the prohibition of having depictions of the human form within the mosque. Right. And then there are some cases where it's like, well, you have exceptions, for example, of things like dolls for children, where the argument is that a doll for a child serves a functional purpose of teaching them about caregiving. So therefore it is an allowable depiction of the human form. And again, even in Islam, like there are some where it's like the prohibition is only in the mosque, and other sects are like, humans should never be depicting other humans. So again, I think that's really interesting. And even, I would say, religions that before didn't have prohibitions. So for example, it was pretty common as a fad in India for a while to have like arati, to have a robotic arm do it. And then and it was not very controversial. It was like a fad and it was happening everywhere. But I would say like within the last couple of years, there's been a lot more pushback of saying like, wait, is this somehow sacrilegious? Is this somehow problematic? So
wait. What are you adding an arm to? What are they adding an arm to?
So there is a ritual for Ganesh where you wave a candle or something else around the statue of Ganesh. And it became a fad for an industrial robot arm to do this ritual.
I guess it depends on how Ganesh feels about it.
That's very cool. On the other hand, that does seem like if you're supposed to do it, you should do it.
Automating religion
seems a shortcut that perhaps, I don't know. Okay.
But again, it's all depending on your viewpoint. I mean, Tibetan Buddhism has had prayer flags and prayer wheels for centuries.
Right.
And I was going to ask you about religious rights for robots, thinking that was just beyond my comprehension. But I do believe that if our iRobot vacuum cleaner died, I would,
You'd what? Give it a Norse funeral?
Yes. That little sucker annoys me. But no.
But you make jokes. But actually, there was a very famous instance where they had a mass funeral for Aibos in Japan.
Oh yeah. That was sad. And I know people get really attached to their home robots, like the vacuum cleaners. Wow, that is a fascinating topic.
Well, it sounds like something. The initial impression is it sounds like, what are you talking about? that doesn't make any sense. But if we don't start thinking about this stuff now, when robots are even bigger parts of people's lives, people won't have thought about all of these implications and how all this stuff works. And it does go to stuff like you're saying, like people's personal relationships with robots, which is going to extend into religion. So
I was thinking as a comparative religious class,
yeah.
an applied comparative religion.
Yeah.
I have to share this tidbit though while we're talking about it, because I'm like, I don't know where this slots in this conversation, but like I'm so excited about the detail. So I mentioned just in passing, like, well, what happens if we become cyborgs to our religious life? And so there's a bunch of transhumanist organizations that are also tied to religions. So there's Christian transhumanist groups and Buddhist transhumanist group. But the largest religious transhumanist group is specifically the Mormon one. And there are religious reasons why that's the case, specifically that there is a mandate to make yourself more godlike. And so the people who are adherents to Mormon transhumanism are under the belief that if I am supposed to make myself more godlike, I should be using any means at my disposal to do that, including technology.
All right. I'm glad that we can have different opinions because it will lead us in many interesting directions. I'm not sure that I want some of the transhumanist stuff, but maybe that's just because...
What if you had filters in your eyes that blocked out all blinking lights?
I would love that.
See?
Oh, so good. But I could just wear an eye mask, and then I can block out everything.
That would cause other problems.
Trade-offs all the way down.
Exactly. We have a couple of listener questions that are mostly about soft robotics, because that's what I asked. Are you ready for those, or you want to continue? I mean, a part of me just wants to talk about religion and robots because there's so many fascinating things. What about you, Kari? Do you want to go on or stay with religion?
I mean, it's funny because since you sent me an outline ahead, I prepped about soft robotics and I didn't prep about religious robots, but I'm happy to talk about either.
Well, let's get some listener questions in, and while Chris and I formulate some other religious ones. Bailey asked, how realistic or unrealistic is Baymax? And if anybody doesn't know who Baymax is, it's a character from Big Hero 6, which is an animated film, as well as there's some add-ons with TV shows. It's a large helper robot focused on medical things.
And it's kind of like made of balloons.
It's inflatable. It's made of balloons. At one point, it gets a cut and it uses tape to fix itself. It's also very sentient, but that's what happens in animation.
Yeah, I think that when you ask how realistic Baymax is or isn't, it's kind of it depends what you mean by realistic. So all of the robots in Big Hero 6, the animated film, are actually based on ideas of robotics research that was current at that time. So collaborative swarm robots and soft healthcare robots were things that appeared in the movie that they used specifically because people were researching these topics. And at least with roboticists I know, there are definitely people who are working on healthcare robotics. There are people who, especially things like feeding people or being able to turn people and be able to sense if they are going to have bed sores or other problems from not being moved. People are definitely working on those problems. So I don't think Baymax is unrealistic in that sense, that people are going to continue to try to develop healthcare robotics. On the other hand, what is unrealistic about Baymax is that Baymax is such a multi-purpose robot. I think we're going to see, unitaskers for the most part, or things that have very specific applications, because Baymax is like very widely applicable in terms of the things he can do. He's a mental health care robot in addition to being able to be a first aid robot.
And he's human-shaped generally.
Yes.
Which for a robot that could monitor someone who's confined to bed and be able to move and help them. There's no reason why they need to be human shaped.
Exactly.
What about the mental health aspect of it? There are robots that are supposed to help you with, let's say, remaining positive in negative situations.
Yeah, I think that part of it is very realistic. And then especially in terms of like companionship robots, if you look at something like Pero, the seal robot, I mean, Pero is a mental health robot.
Pero's great. Okay, so William asks, what's the definition of a soft or hard robot? Can you have blended ones?
I definitely think you can have blended soft and hard robots. I think that very few soft robots are actually 100% soft. Most of them have some hard components still these days. And I, in general, am not a purist. I'm like, yeah, mash it up, whatever works. But I usually define soft robotics as robots that get their primary function and capabilities from soft components. And then to like roll that all back one step further, I find it useful to define softness because soft means a lot of things in the English language that have nothing to do with each other. So when I talk about softness and robots, I'm usually referring to flexibility, compressive elasticity, or tensile elasticity. And so that comes down to, can it bend and then bend back to another shape? Can you squish it and have it return to another shape? Or can you stretch it and have it return back to its original shape?
So you have the soft robotics being part of the mechanism. So if I have a gripper arm that's just super squishy plastic on the end where the grippy part is, that doesn't count.
To me, I wouldn't count that. So there are, so another example that I'm like, people may or may not say like, this is a soft robot. For me, a lot of sex robots I wouldn't consider a soft robot because the majority of their functionality is coming from the hard components underneath that are just covered in like a humanoid layer that's squishy.
But if I had my gripper blow up into the shape of a claw and be able to surround whatever it wants to pick up, that's more of a soft robotic. Even if the rest of the arm is hard, that part that encases what it needs through pneumatics is the soft robot part.
Yes, that is how I personally would define soft robotics. And like we've talked a lot about pneumatics because I feel like pneumatics is a good entry point for understanding soft robotics. But I definitely also don't want to say like pneumatics is the end all and be all of soft robotics.
Well, and you mentioned stretchability and flexibility and squishiness, but setting aside squishiness, the other two I can do with paper and flexible circuits. At what point does that become soft robotics?
I would say if you are using the paper specifically for its flexible properties, that it could be a soft robot.
So we had Carl on the show recently, Carl Bourget. And he does this thing, Flexar, with a flap actuator. And he uses a magnet on one side and what looks like an antenna on the other, or a speaker wire. And he can make it flap back and forth. I sent you the video. Did you get it?
I did. I saw it. It's amazing. I want to play with it.
Is that a soft robot component?
I would call it a soft robotic component, but I don't know if Carl would.
Well, let's call him up and find... Oh, wait, no, it's like...
Surprise!
3 a.m.
Carl's been waiting this whole time to answer this question.
Have you seen other technologies like that? I mean, I understand the pneumatic stuff, but the other flexible mechanisms like that.
Oh, yes, definitely. I mean, I ended up in my class, at least, I give them long lists at the beginning. I'm like, things that have been used to make soft robots. And then I like have a long list of materials. And then I'm like, ways people have actuated their soft robots. And then I have a long list of ways people have actuated it. And honestly, like, there's so many ways. And that's one of the things that I think is most interesting about soft robotics as well, is that lots of times there are robots that have nothing in common with each other except for their like material compliance. Or there are things that will have multiple forms of different drivers at the same time. So you'll have one that's like both photonic and magnetic in the same robot working together.
Photonic?
So actuated by light.
Huh.
So essentially, if you take a soft material and then a way that you can manipulate that soft material, those are pretty much the components of how you can make a soft robot. So it's like, oh, is this actuated with, there are plenty that are actuated with a magnet. There are some that it's used things like nitinol, where it's like, okay, you heat it up with electricity and then it flips. So I think that maybe people's conception of what a soft robot is more centered on things that are pneumatic. But I'm very excited about kind of the nonlinear of behavior of other things. One example I would give is that in my class this year, I wanted to do a co-learning experience. So we made our own conductive polymers around soft materials. And so we just like made a big dye bath of polymer. Everyone brought their own soft samples. We threw them all in a vat and mixed them up. And then when they came out, we tested their electrical properties, and then people applied them to different problems. And one of the ones that turned out beautifully was they had made conductive sponge. And because of all of the nonlinear behaviors of a sponge, it was very possible for them to detect different kinds of gestures. A slap was different than a poke was different than a squeeze, because a sponge is so nonlinear in its behavior.
I don't understand they brought things and threw them in a pile. What was this, resin?
It's a project actually you can see on Hackaday. It's called Polysense. I was introduced to it by Cedric Honet, who is one of the people who reverse engineered a product that they were interested in and came up with this very simple method for making your own conductive polymers. And functionally, the way it works is simply like it being a dye bath, but instead of imparting color, it's wrapping the polymers into the fiber as it forms.
Okay, I have opened the page, but I am not going to look at it because otherwise I will just get very distracted. Okay, so that would make your own sensor as well as actuator.
Yes, and so that's kind of central to the way I'm approaching soft robotics. So the thing is, my class is called Exploring Concepts from Soft Robotics, as opposed to something like Intro to Soft Robotics. And that's because for me, my goal, again, when I was talking about the book, it was very similar. It's that I want people to look at materials and say, what if I use this material in a way it was never intended to? Can I make something totally novel and exciting by reimagining what's possible because of a material's inherent properties?
Fascinating. We may have to invite you back very soon after I've played with this. What you mentioned the sponge. Were there other interesting things that happened?
That was the one that the students took it the furthest. They decided to do their final project based on that initial experiment that we did. Someone else ended up accidentally making a silicone hand conductive, which was not something that we thought would be able to happen. But they had made a glove conductive. And then while you're working with this material, sometimes it sheds little dust of this polymer. And so they had shoved a silicone hand cast inside the glove, which then coated it entirely in this conductive powder. And then they could use that as a sensor, which was like a total surprise. Another thing that happened was that someone decided to dye flowers So they artificial flowers, and those they took the polymer beautifully, and they could be things like capacitive sensors. So you could make a whole thing of flowers you could be near to cause something to actuate or to light up or whatever electrical purposes you would want to use them for. One of the things I threw in was a pine cone. Which I found a surprising thing about pine cones by doing that, which is pine cones close up when they get wet again.
Huh.
And I was like, oh, I could design a very slow interaction if I time-lapse filmed it by like embedding things inside the pine cone and then soaking it in water, having it close, and then I have it open very slowly.
I could add some origami to the next bath. I have some that's pretty water resistant.
Mm-hmm. But it has to also be absorbent.
Oh, yeah. Somewhere on the edge of, yeah. Okay, now that I'm full of ideas, let me get back to the listener questions. Is there a simulation software for soft robotics from UE?
So the answer is kind of, which is, again, like all these questions are always like, maybe, depends what you mean. Yeah. So the thing is about simulating soft robots is that it is much easier to simulate things that are flexible than it is to simulate things that are compressed or stretched. So if you wanted to look for things that like flat patterned inflatable style stuff or fashion-based stuff, like there will be models that you can use that will be able to predict the behavior of those things. What happens though when you start to get into this like stretch and compress area is that kind of the number of variables go up in terms of the behavior, and they're harder and harder to characterize. And one of the reasons they're harder to characterize is because the tiny details in terms of manufacturing will become much more pronounced as you get into these like complex behaviors. And then another thing that happens is as these things cycle over time, their behavior also changes.
Which makes it hard for a production application.
Mm-hmm.
Yes. But it's also like in terms of like the predictive nature. So like in terms of things that are like stretchy, maybe there's like proprietary, like making car parts that are out of like galvanized rubbers that are specifically very precisely manufactured where they could predict the behavior. But if you're doing like even DIY in like an academic setting, if there's a gap between your manufacturing capability and like your modeling capability, it will often be a surprise what the behavior is. So when you see models of things that squish and stretch that have kind of, again, to say like modeled capabilities in terms of how they're being controlled, like control feedback, a lot of times what happens is they may have developed a model before they made it. They made it, it didn't behave precisely like the model ahead of time. It has a different behavior. And then they feed back in the real behavior into the system, if that makes sense.
Totally. But do you write your own simulation software, or is this just experimental?
I think I don't work in simulation, but I think most people are using, for example, what's the name of it off the top of my head? I'm drawing a blank at the moment. But there are a couple of different academic models that people use that you can feed your system into after the fact to then turn it into a control model.
Okay, I may ask you for those later. We'll put them in the show notes.
Perfect.
Let's see, from Sila. How is power handling and delivery different from normal robotics?
So power handling and, sorry, what could you restate that?
Power handling and power delivery. How is that different from normal robotics?
Again, it will depend on what your system is. You know, if you're working with electromagnets versus working on light, a lot of light controlled things nowadays are getting more complex, which is quite interesting because now you have wireless LEDs. And now that you have wireless LEDs, your control system can be totally off-boarded from your soft robot, which is really exciting. So again, kind of if you think about the domains in which how you can control a soft robot, that answer is as complex as what it is you're doing. So is this a cable control? Is this thermally actuated? Is it magnetic? Is it a chemical reaction? So that question doesn't really apply equally across the domains of ways to drive a soft robot.
Have you played with the wireless LEDs?
I have not, but it's definitely on my to-try list now.
I know. So if anybody hasn't seen these, Adafruit has a small inductive coil and 10 wireless LEDs for $15. And the LEDs look like, they're just little LEDs alone. They are tiny little marbles, not really round, but sort of. But maybe a third or a quarter the size of a normal regular marble.
Okay, so like large BBs?
Large BBs. Okay, I'll go with that. And you put them near the coil and they light up. And if you think about that, the coil could be whatever you want and the lights could be embedded in whatever you want. Now you have a stuffed animal that lights up whenever it gets put to bed or something like that. It's just
without batteries or any other electronics in it.
Right, without the electronics in the device. Instead, the electronics are part of that coil. Yeah. Wireless seems like the way to go, but I don't think we can live in inductive coils. That seems harmful.
Fine.
It's all fine. Are there other soft robotics things that are kind of like that?
In terms of
magicalness.
Biological robots to me are like pure magic.
Indeed.
Like, you have to feed them. They eat the thing they swim through.
Okay. What biological robots are you talking about in particular?
There is one that is a ray that is made out of rat heart cells. That is wonderful. And then they made a second generation one that's in a different sea animal shape, but it's eluding me at the moment. But if you look at rat heart cell ray, you can then see their newer work at the same time. But to me, it really is magical to just see these cellular things swimming through some kind of nutritious slurry.
And we talked a lot about that on the last time you were on the show, which was like 200 episodes ago, which is just, it's a long time. It's a good thing I get to talk to you more often than that. Could a DIYer build a simple, soft robot, maybe something that could give a foot massage?
So a foot massage is an interesting case because when I read that question, I was thinking, a lot of times massage devices actually rely on their hardness very intensely. So things like Theraguns are like literally like hard thumping devices.
Yeah.
So the kind of massage you could get out of a soft thing would be very different than the kind of massage you would get out of a hard thing. So it depends on the sensation that you want to get. I think that like when I think of a soft robotic massager, I'm like, well, you have the realm of compression as a possible feeling you could have. I think might be truly novel about a soft robotic massager is if the kind of massage you like is like a tickly feeling. Like maybe that's something soft robotics would be uniquely positioned to do. But I do think that DIYers can build simple soft robotic concepts. I guess I'm biased because that's what I do is I teach people who don't know anything about soft robotics how to like build their simple idea. So I do think that is quite possible.
What is a simple soft robotic thing that someone could do to get their feet wet, assuming they understand traditional robotics?
I think that probably the classic example is going to be a gripper of some kind. You're going to make either a positive pressure gripper that goes around something, or you're going to make a vacuum gripper that's a jamming gripper. That's very popular in terms of like the world of possible marketable robots, but it also is just like a good way to get started, partially because there's so many versions of them. So if you like Google DIY jamming gripper, you're going to see people who are doing all different versions of that, and you can pick the one that appeals to you, that works best with the tooling that you have. And similarly, you can do that with a positive pressure gripper. So you can see like there are versions of that where it's on Instructables and like you're just using a cardboard mold and wrapping it with ribbon for external restraints. Or there's some versions where you like 3D print some beautiful mold. There's ones that you cast it in parts with laser cut pieces. So you can find a version of one of those projects that will definitely be a good entry point if you want a guide, and will match the tooling that you have. I think that you already identified, and we spent a lot of time talking about kind of the satisfaction of using a hand pump versus using something that's computer controlled. So for me, I don't mind prototyping with just hand pumps and kind of other kind of simple ways of controlling air. But I think the most important thing that you probably need to think about in terms of like roboticizing this is, do you want it to be, vacuum and ambient if you're making a jamming gripper? Or do you want it to be, if you're making a positive pressure gripper, is it positive and ambient? Is it positive and vacuum? That will definitely change the speed at which your actuation happens.
And when you say positive, that's you're holding it when it's in vacuum, or you're holding it when it's under pressure.
Yes.
And then negative would be you're releasing it under that condition.
Yes.
I am. Let's say you don't want to play with air.
Yes.
Are there other? Can I still do a gripper of some kind?
You can do cable control things. That's another good thing that you could try out. You could try out something where you've made something that's a flexible part, and when you pull on a cable, then it causes that part to flex to grip around something. So that's another way you could make a gripper if a gripper was the thing you wanted to do.
Oh, we did. I think the last time I talked to you, after I talked to you, we talked about straws. And I made little straw fingers by cutting in certain areas.
Yes.
And then you can roll, and then you can use a motor to roll up the string, and then the little straw fingers.
Oh, okay. Yeah, like almost puppet.
Yeah, it was
kind
puppety fingers.
Yeah.
Yeah, that is like the easiest compliant system to make that has that function. But there's all kinds of things too. Like if we're talking about people who are already working in the digital fabrication space, there's a lot that you could do with like flexible filaments and print in place kinds of things that would also have that same function, but maybe be more durable or more aesthetically pleasing than a straw.
Oh, yeah. I mean, it's basically you have a tube and you can do things interestingly with a tube that can bend. And it's just that straws are cheap. And
straws are easy.
Hanging around.
Though weirdly, straws are getting harder, at least in New York City. I used to send my students to McDonald's because they had great straws that were for milkshakes, and they made lovely, lovely bending things. But then this year I sent them and they were like, they've converted all to paper straws. And I was like, oh no, I need to figure out who's using very eco-unfriendly straws.
Let's see. Christopher, do you have any more questions?
Yeah, I think briefly, we barely touched on it, but is 3D printing something that's getting more useful in soft robotics? Because I know there's lots of different filament types that are squishy or flexible now, but they seem to have some issues that regular printing doesn't.
I would say definitely I would say that it was already very useful if you like working in silicone to make molds.
Right.
So that's one thing. Another thing is that you can print in flexible things either with Ninja Flex style things or by using resin printers that have flexible filaments. And then I also, because I have kind of the resources of a university around me, I've been making up workflows to use other things. So for example, doing high heat resin parts that then I vacuum form the molds. So it's kind of just, you can play around with the digital fabrication tools to do all different ways of working with these materials. One that I'm very interested in, but haven't done yet, is essentially you can make molds using a resin printer where you make the mold itself eggshell thin. And so then you no longer have to worry about undercuts because you just crumble the mold away when you're done.
Okay.
And I'm very excited about this and have not tried it yet.
Huh.
I don't do a lot of 3D printing. What does that mean, Christopher?
It means where you've got areas that you've got difficulty.
The overhang.
Yeah.
That part I understand, but
it's easier to deal with afterward because then the mold just disintegrates. You no longer have.
Oh. Yeah,
so
okay.
To kind of use an opposite example, probably more people are familiar with things like lost wax mold, where you melt away something from the inside of something else. But this is the opposite, that you do the outer part of the mold is intentionally disposed of and broken.
So you peel it away.
Yeah, no, I got it. I finally got it.
I was imagining it myself.
I feel like some of the reasons I don't think I can do soft robotics is my own creativity. I've always put it off because pneumatics is hard, pneumatics is expensive, loud, big, just not an area I'm super excited about, despite the fact that I have 15 pumps on my desk upstairs.
I was about to mention that your desk is currently covered in a pneumatic system, but between strings and bendy things and being able to build molds, I think really it's me limiting me, not the technology.
I think that one of the things I definitely face with students is that people can be really scared to get started because it does seem so daunting. It seems so daunting to not have a tutorial to follow, to have to kind of create your own path. And for some people, that's very exciting and that's where they want to be. And then for other people, they want to be there, but it's still, they feel inhibited. And so I do think that a big part of what I do is encouraging and supporting. Just to say hey, it's okay if the thing you want to build is a thing that you don't know how to build yet. We know there's the path of failure along iteration, but you will find it so rewarding the first time you build something and it works. And I definitely went through that this semester with someone who they came to my class saying, I want to make architectural scale inflatables. And I was like, great, this is a thing we can do together. This is a thing I can guide you. We have the tools, we have the fans, we have the material. Let's do it. And then
a bouncy house?
Yeah, like a bouncy house. But more with different aesthetics and maybe
that's fine. Yeah.
And until they got started, every week they were like, I didn't feel ready and I don't know how to start. And then I was like, okay, let's do it. Today we're sitting down, we're making the thing, we're making the first. And as soon as the first iteration was out, that person was off and running. They just really needed to be supported to the point where they got to that point. So maybe you just need a cheerleader.
Or a project that I care enough about to take the time. But I agree with the teaching cheerleading part. There's been so often that all anybody ever needed from me was for me to say, yes, that's a great idea. Off they go. And it's that my opinion doesn't matter, right? But that's all they needed. So yeah, if anybody is in that current state, yes, I think that's a brilliant idea and you should try it out.
Fantastic. I agree. I'm sure that you'll either have a great product or you'll have a great story.
Exactly. Kari, do you have any thoughts you'd like to leave us with?
Let's see. I feel like if I were going to leave us with a thought, it would probably be about the power of an invitation. So a lot of times people are like, well, how did you end up on some weird career path where you're like making Broadway costumes and spacesuits and puppets and soft robots and dressing robots in clothes and making robots out of candy? And I'm like, it was all a series of things I never planned. And then someone would invite me somewhere. They would give me a possibility. And then I would say, like, you're right. Maybe I should make puppets, or maybe I could be a NASA contractor. And that when we are in a position to invite another person to join us, that's so beautiful, both in terms of like human connection, but also like amplifying our capabilities and our creativity by inviting other people to be a part.
So I'm hearing share your toys.
Share your toys. Share your enthusiasm.
Our guest has been Kari Love, fellow and adjunct professor at NYU ITP, the Interactive Telecommunications Program. Her book is Soft Robotics, a DIY introduction to squishy, stretchy, and flexible robots. And her website is karimakes.com. That's Kari makes.com.
Thanks, Kari.
Thank you so much.
Thank you to Christopher for producing and co-hosting. Thank you to our Patreon listener Slack group for their questions. And of course, thank you for listening. You can always contact us at show@embedded.fm or hit the contact link on Embedded FM. And now a quote to leave you with from Hero in Big Hero 6. I fail to see how you fail to see that this is awesome.